Okay, we are now in 8.4 diffraction grating. And then we are starting with it. Essentially, this is the formula you need to remember and know how to calculate. Okay, that's the solution. This is close to the wavelength of light. Wavelength of light is about 10 to the power minus 7. That's your laser. For paper 5, you need to know laser produce light that are coherent, unidirectional, monochromatic. AS, you don't need to know that much, but paper 5, you need to know. Neon laser is used in classroom demonstration and laboratory experiment. It is Rickish pink. Usually all this you will get a mark. Rickish pink, wavelength about 630 nanometer. Right? That is your diffraction grating. That's your laser. Right? The screen is the wall. That's all you will get. So you need to remember the center one, the direct one, straight through. Right? That's the wavelength of the light. Helium neon laser. Right? Order m or n equals to 0. That's the first one. And then m equals to 1 on either side. Then m equals to 2. Right? Or you prefer the mass way, you can put a -1 here, -2 there. Different wavelengths are diffracted at different angle according to the grating relationship. Measuring a wavelength, that's how we will do it. Measuring a wavelength, there's your diffraction grating here, there's a laser, there's your screen, right? Can be your wall. M equals 0 is direct through, M1, M1, M2, M2. And then we can look at this one, right? Which is that one there. M1, there's a distance Y. There's a distance Y here. There's a distance D. Right? You want to calculate the angle theta. So tangent theta equals to Y over D. Measure, right? Distance D, that distance there from the screen to the diffraction grating. There's a D using a meter rule. Distance between the center M0 and M1, M0 and M1. Using meter rule because the distance is quite large. Diffraction grating formula. There's a diffraction grating formula. Small d is the grating spacing, lambda is the wavelength, theta is the angle of diffraction, m or n is the order, can be whole number, 0, 1, 2, 3, and so on. Number of lines per unit length is n, is written on the grating. From this, n can be calculated. Okay. M equals to 1 if the first spot next to the center spot is used. Wavelength of light can be calculated. Right? You know theta, you use m equals to 1. You know d, calculate from n given on your diffraction grating formula. Then from there, lambda can be calculated. Don't bother about too much about all this stuff. Right? These are each of the slit produce spherical waves, and then they interfere, produce your constructive interference pattern and destructive interference pattern. No? Circular wave interfere to give different order images of the slit. At point of constructive interference, we see bright spot and dark spot at point of destructive interference. So m equals to 0 basically is the one directly through. So these are all plane wave. Plane wave moving that way. right? M equals to 1 is this one. Right? The first one and the second one and the next one, the third one. Right? Draw parallel to that. Right? Just for your info lah. And that out there will be the screen. Okay, diffraction grating formula. M equals to 0, theta equals 0. Path difference is 0. Suppose plane wave of monochromatic light of wavelength lambda, right? Plane wave from here, fall on the diffraction grating in which the slit separation of the grating is D. M equals to 0 is called the central bright fringe. Path difference of the wave from all the slits are 0. For constructive interference, right? I don't think you need to know how to use the formula lah. Don't need to know how to derive lah. Right? There is your plane wave at an angle theta. Theta there. So we look at this triangle, which is this one. Right? There's a distance d from center to center. There's an angle theta. There's 90 degrees. So that's your path difference. That distance, path difference. That one has to travel longer distance. For the nth order, d sine theta equals to m lambda, you get a bright spot, constructive interference, where m is an integer number, 0, 1, 2, 3. Okay, maximum number of order, right? There is direct one, m equals to 0. And then 90 is here. That's 90. Right? You cannot go to the other side. You only want this side. Diffraction grating, the pattern should be on this side, not on that side there. So the largest you can go is 90 degrees. Since the maximum diffraction angle is 90 degrees, this limits the number of order or spots of light that can be observed. So maximum order theta equals 90 degrees. Right? We're just using this formula, that's all. Take your d down. So 90 degrees sine theta equals to 1. So we use m lambda d equals to 1. No? Maximum number of spectral line is 2m plus 1. Memorize, right? 2m because either side there's 2 first order and then plus center one 0 order. 2m plus 1. Experiment using white light. White light, the center one will be white. Diffraction grating allow us to separate light into their individual colors or wavelength, and the resulting spectrum is in turn provides the useful information about the light source. Okay, so we know it's white light, that's why we see all this color. This is white light, there's violet, that part is red. The central fringe is white, as all colors have a path difference of 0. Right? That's why you see white. Different colors are diffraction at different angle. Shorter wavelength, but example violet, is deviated less. Right? Violet is here. Longer wavelength, red, deviated more. Okay? Just use the formula to help you understand. Advantage of diffraction grating compared to double slit arrangement for measuring wavelength. Maxima are much more sharply defined for diffraction grating. That one, the maxima, I don't know where is the center. Where is the center to center, right? There's a bit of uncertainty. The beam will pass through hundreds of slits instead of just 2 slits. Double slit, 2 slits only, right? 2 sources of light. Whereas diffraction grating, you got many slits, thousands, hundreds of slits. So the intensity of the maximum is much higher. I can compare. There's Young's double slit, there's diffraction, there's diffraction grating, single slit, double slit, diffraction grating. Larger angle between the maximum can be measured with greater precision than the distance between the double slit. Right? We don't know there's a lot of uncertainty because the distance is very small for double slit, whereas this distance is large. Right? So more greater precision. Right? If we want to analyze what is the gas inside there, there's application, or we want to study the star, we can use diffraction grating to analyze the wavelength that's present in the star, or the color that's present in the star. Diffraction grating is an immensely useful tool for the separation of spectral line associated with atomic transition. It acts as an upper super prism separating different color of light much more than the dispersion effect in prism. Right? This, if you put hydrogen gas, that's what you will see. You don't need to know about spectrometer, that's how it looks like for your info. We measure angle rather than length. Okay, I don't think we will bother about all this. If you want, you can read up yourself. Right? We measure angle. D we can obtain from the diffraction grating. And then N which order that we want to measure. And lambda can calculate. Okay, we have more or less completed. So let us try some question. Hope you have a chance to try that. Okay. In the diffraction grating experiment, label the following. Right, that's your diagram there. Label the following: M diffraction grating, M equals to 0, M equals 1, M equals to 2. Plane wave and normal incidence, that's a plane wave and normal incidence. State the diffraction grating formula and the significance of the symbol used. Right, you should be able to say this is 0, this is 1, that's 1, 2, that's your 2. What is the small d? What's the name of the small d? Can you remember?
Uh, 4D, I think is the wait. Oh, it's not separation.
Slit spacing, distance between the slit. Theta?
Wait, I thought slit spacing is Y.
No,
Oh
y
no,
is
fringe spacing is Y.
spacing, fringe
Oh
spacing,
yeah. Oh okay. There's angle.
diffraction angle, angle of diffraction, M, order of diffraction. Then memorize
Yeah.
the formula. That's all essentially for this topic. Very short topic. Then the other one, relationship between D, theta, and Y.
Okay.
What's the relationship?
D and Y. D and Y directly promote. I'm intuition.
So what's the
Hang on.
relationship? Yeah, look at the diagram there. There's your angle theta, there's your D, there's your Y. So what's the relationship between the three parameters? This formula you must be able to derive also. Tangent theta is equal to Y over D. Okay now. These two formula is
Yeah.
and then know the significance of each of the term. Okay, what's the answer? And monochromatic light is shown on the diffraction grating. Sharp lines are observed on the screen. The sharp lines. Yep. What's the
I think
answer?
it's I put D.
Not evenly spaced. Okay, not evenly spaced.
Oh, what do you mean? Oh, it's not evenly spaced?
Let me show you. There, not evenly spaced. Okay,
Oh, okay.
I
Yeah,
think we
okay,
watch
okay.
the YouTube those. Watch YouTube for a short while
Yeah, sure.
so that you can understand what are the things real life experiment. Okay, let us make a start. If you got problem, let me know.
Yep.
Normal instance method.
There's your diffraction grating, laser.
Great.
Grating is kept between the screen and the source.
Right, put the diffraction grating into the folder. You just see. Right, you can see that it's not evenly spaced.
Adjust the grating material such a way that the undiffracted beam hits the 50th division of the scale. Measure the distance between the screen and the grating. When grating surface is kept perpendicular to the incident beam, the laser beam gets diffracted and first and second order diffractor spots are seen on the screen.
There's your Y.
Oh,
There's your Y also from center to.
Measure the distance of the spots from the 50th division of the screen. Repeat the same for various distances and hence find the lambda of the source beam.
Okay lah, you enough already as long as I show you how to real life experiment. Okay, let's try the question. If we got time, we can start A2. Finish everything easier. Okay, how about this question? What's the answer?
put B.
No, not B. C. Can
Eh?
you put a screen
Oh,
there?
okay.
It's not evenly spaced. Tend to be wider as you go different order. This one is too wide. This one only one order. You have more order than that. Okay, what's the answer for this one?
Uh, graph A,
Why do you say it's graph A?
that's the equation.
It's the sine graph, yeah,
Yeah,
correct. Sine graph. Okay,
okay.
that's the formula. You are basically applying your diffraction grating formula. How about this one?
Um,
Yeah, magenta coming in. Magenta is blue and red color.
red is on top, right?
You have to decide yourself. Use the diffraction grating formula if you have to use that to help you.
Oh,
Yep,
I think it's either B or D.
donkey.
Oh, it's donkey,
Use
ah.
the formula, donkey. Right? Center both blue and red together. Then blue is diffracted less, red is deviated more. Sorry, deviated more.
Then why B cannot?
Cannot you must have blue This one this is the first order This one tell you the first order is red, the first order is blue. Cannot be like that Must be this way
Oh, okay, okay.
How about this one? Can calculate out using the two formulas I've given you. Three formulas.
Hmm.
Yep. What's the answer? Wavelength of light.
Which formula to use?
This formula, D equals 1 over N. To find your D.
Oh,
And using your tangent theta, right? Measure your Y. Your D is given. Calculate your Y. And find your angle theta first. After that, use the grating formula and calculate your lambda Can.
can.
Okay, I think that's all. Let's go to A2 Anything else? Anything else? I want to read calculate. The rest you can try out yourself Maybe you can try one more Differential grating consists of 600 lines per cm. Calculate the separation between the slits. Maximum of number of spectral lines can be observed for rate of wavelength 7.8 10 to the power minus 7 meter. Right, solution. N is given. That's your capital N. Right, is in cm. So invert it, the answer is in cm. B, maximum number of line. Right, can use the formula, diffraction grating formula. Sin theta equals to 1. Or theta equals 90 degrees. And we use this formula D equals to m lambda from here. Calculate your m, right? It should be a whole number. M equals to 2. Remember, m is order. 2 lines on both sides. The central line, so 5 lines, so 2 on each side of the central line. Okay. Can any problem? Let me know what's the problem.
Can lah, I just like need to know how to apply the formula.
Okay, we got 10 minutes. Then we will make a. Okay. We make a quick start. Right? Just in case we cut off, we'll see you next week.
Okay.
Right? Got 9 more minutes. Motion in circle, topic 12. Right? That's your structure for paper 4. 2 hours. 38.5% of A level. Right? These are the topics that you'll cover in A2. Circular motion, gravitation, temperature, ideal gas,
What's ideal
thermodynamic,
gas?
oscillations, electric field, capacitance, under electricity, under magnetism, magnetic field, magnetic force, motion of charge in electric and magnetic field, electromagnetic induction, and AC. And under modern physics, quantum physics, 22, photoelectricity, energy level, wave particle duality. Under medical physics is our ultrasound, PET scan. Under nuclear physics, binding energy, radioactivity. Under astronomy and cosmology, right? That's the 14 topics. Right? All these are application of physics. Okay, there's your syllabus. Uniform circular motion. Uniform circular motion means that the body is moving in a circular path with constant speed. So the key is circle, moving in a circle or circular path. Constant speed, not velocity, constant speed. That means no tangential acceleration. Along the curve there, circular path there is no acceleration. Because tangential acceleration. Right? Velocity is different. Velocity different direction, but speed is the same. Right? You can see many examples about Earth, circular motion, roller coaster, uniform circular motion, right? Moon moving around the Earth, or motion of satellite. That's topic 13, our next topic. Then cornering. Cornering is not mentioned in syllabus. I just teach it for extra knowledge in case it come out. Cornering. Okay. Linear motion. You have an origin there. Then we are interested in displacement or vector quantity. Whereas for circular motion, you have a starting point as well. Anywhere you can call your starting point. There's your particle. There's your circular path. And that angle is called angular displacement. Instead of calling angle, we call angular displacement. It's a vector quantity. Then we have velocity. So this one, we also have velocity, but we call it angular velocity. Right? We will define the term. Newton's first law tells us when the path of the particle changes, a resultant force act on it. Right? Where the path of the particle changes, even though it's constant speed, path changes, there's a resultant force acting on it. And then second law tells us how to calculate the magnitude of the force, F equals to ma. Right? That's the direction of the force. So drawing analogy between linear and circular motion, time is the same in circular and linear motion. For displacement, the symbol we use for linear is S or X. For circular motion, we use angular displacement. For velocity, we use U or V. For circular motion, we use angular velocity omega. Acceleration is A. Angular acceleration or tangential acceleration alpha. So relationship S equals to R theta. Relationship V equals to R omega. A equals to R alpha. Force causes linear acceleration, while a torque causes angular acceleration. That means the angular velocity changes. Right? But we are not interested in this one for A2, not required for this one. Right? Our A is constant. A is 0. Okay, that's your circle. That's your particle with velocity V. So these are terms that we need to know. R is radius. C is center of the circle. V is velocity of the particle, or we call it tangential velocity. Theta is, instead of calling angle, we call it angular displacement. Give you a direction. This one is anti-clockwise. Omega is angular velocity. Maths, you don't have to show, but physics, you need to show. What is meant by a radian, they can ask you. Right? Basically, this is a radius. So the arc length is R. That angle is called 1 radian. That's how we define it. Memorize it. It's the angle sustained at the center of a circle where the arc equals in length to the radius. 1 revolution is 360 degrees equals 2 pi radian. 2 pi radian is 360 degrees. That's good enough lah. No need to go and calculate. You can calculate 1 radian if you want to lah. What's the relationship between the following parameters? Theta in radian, R radius of the circle, S is arc length. Right? That's your math formula. S equals to R theta. Show that 1 revolution equals 2 pi. This one can come up. Has come up before. Right? 1 revolution, circumference is 2 pi R. Right? Arc length, S equals to R theta. Theta equals to S over R. Right? Cross multiply, that's all. So S is 2 pi R divided by R. So theta equals to, we have shown already, 1 revolution is 2 pi radian. Can? Anything not clear?
Yeah, can.
Right? It's just repeating only lah. Right? 2 pi radian is 360 degrees lah. What's the unit? What is the unit? Angular displacement. Radian is the angle. Right? Angular displacement. Unit is radian. Vector quantity. Angular velocity, angular speed. Rate of change in angle swept out by the radius. Memorize it. These are the free mark that you are supposed to get if it comes out. Angular velocity, theta over t, or d theta dt. Usually they don't expect you to use calculus. Angular velocity is a vector quantity, either clockwise or anti-clockwise. Unit is radian per second.
Teacher.
Yep. What's the
Oh,
problem?
never mind.
Sometimes I use small R, sometimes I use big R.
Because
Yep.
because it's like you say angular speed, then now angular velocity.
Oh, speed is just a is a scalar. Velocity is a vector. So it depends on what you
But
use.
what's the difference?
You call angular velocity is a vector. You call angular speed is a scalar.
Okay.
Just like speed and velocity. No? Speed is scalar, velocity is vector. Okay?
Okay.
Speed and angular speed. For a particle moving with speed v in a circle of radius r, how is the angular speed related to v and r? Right? V equals r omega. Right? V